Hey there, and welcome to The Explainer. Today, we are tackling something you've probably seen 1,000 times, but maybe never really, thought about. That reddish brown stuff that just seems to take over anything made of iron. Yep, we are talking all about rust. Right? Of course you have. It's on old cars, park benches, rusty nails. It's literally everywhere. It just feels like a natural part of the world, something that just happens. But what if I told you it's not just a simple color change?
That's right. What we casually call rust is actually an active, ongoing process of destruction. It's like a slow motion chemical attack, and today we are going to figure out exactly how it works.
Okay, so here's our game plan. We're going to start by properly defining this whole destructive process. Then we'll look at the different types. And then we get to the really cool part, the secret science of how rust actually forms. After that, we'll see what speeds it up and, most importantly, how we can stop it. So first things first, scientists and engineers don't just call this rusting. Nope, the official term is actually a lot broader and way more important. And here is the word you need to know, corrosion. It's the gradual, systematic breakdown of a metal simply because of how it reacts with its surroundings. Getting a handle on this term is really the first big step to understanding this whole thing. And it's not just about iron. The rust on an old gate and the tarnish on some antique silverware, they're both basically children of the same parent process, corrosion. They're just different examples of metals reacting with the world around them. Now let's build on that a little bit, because it turns out not all corrosion is created equal. There are two main categories that we really need to get our heads around. And the key difference here, the big one, it all comes down to a single ingredient, water. See, dry corrosion can happen without any moisture, like when a metal reacts directly with gases at super high temperatures. But the process we see every single day, the rusting of iron, that falls squarely into the wet corrosion category. It absolutely positively needs moisture to happen. And that brings us right to the heart of our mystery. Since rusting is a type of wet corrosion, it's not just a simple chemical reaction, oh no, it's an electrochemical one. So let's break down what that actually means. Okay, you're going to want to remember this name, electrochemical corrosion. This is the precise scientific term for rusting, and it tells us that electricity, or more specifically, the movement of electrons, is involved. It all happens in this little three-step dance. First step, a tiny spot on the surface of the iron basically decides to become what's called an anode. And right there, iron atoms start giving up two of their electrons. They go from being neutral little iron atoms to positively charged iron ions. So what about those electrons that the iron just lost? Well, they travel to another spot on the metal, and over there, they meet up with some oxygen from the air and some water. The oxygen and water scoop up those electrons, and in the process, they create these negatively charged things called hydroxide ions. And now for the grand finale. Those positive iron ions from step 1 and those negative hydroxide ions from step 2, they find each other, they react together, and they form what scientists call hydrated ferric oxide. And that, my friends, is the reddish, flaky substance we all know as rust. This just illustrates the whole thing perfectly. It's like a tiny little battery in action. You've got an anodic region where iron dissolves and loses electrons, a cathodic region where oxygen and water gain them, and then boom, the final product, rust, forms from that combination. It's a complete electrochemical circuit playing out right on the surface of the metal. So, if rusting is this whole electrochemical process, what are the conditions that can basically put it into overdrive? What factors affect the speed of this destruction? Well, as you'd probably guess, more moisture means a faster reaction. Higher temperatures also tend to speed things up. But what's really interesting is that things like impurities in the metal, the acidity of the environment, think acid rain, and even just how rough the metal surface is, can all dramatically accelerate corrosion. So understanding how rust forms is one thing, but stopping it is a whole other challenge. How do we protect all our valuable metal structures from this relentless chemical attack? Luckily, we have several really effective strategies. The most obvious one is just creating a physical barrier with paint or oil. Another super clever method is galvanization, where iron gets coated with zinc. The zinc actually corrodes first, sacrificing itself to protect the iron underneath. We can also use advanced techniques like cathodic protection, or even change the metal's recipe entirely by creating an alloy, like stainless steel. Wow, okay. So we have really broken down the entire mystery of rust, from what it is to how we can stop it. Let's just do a quick recap of all the key points we've covered. This sequence right here gives you the complete picture. You start with the core definition of corrosion, then you explain the different types. From there, you detail that electrochemical mechanism, you list the things that speed it up, and you finish with how to prevent it. Following this logical flow is honestly the clearest way to explain the entire phenomenon.
So, we've unraveled the secret of rust, revealing this invisible electrochemical battle that's happening on surfaces all around us. It really makes you wonder, what other silent, powerful chemical processes are constantly at work, building up and breaking down our world in ways we rarely ever get to see?